Imagine pressing your gas pedal and getting absolutely nothing in response, or feeling your transmission stuck in a single gear while a warning light screams at you from the dashboard. That is the frustrating reality of the P0903 trouble code. This is a generic powertrain code, which means it can pop up on a wide variety of vehicles, from Toyota and Ford to Mercedes and Hyundai, but it is specifically tied to the clutch actuator circuit. Now, do not let the word clutch confuse you if you do not have a clutch pedal. This code usually appears in vehicles with semi-automatic transmissions. These are really cool systems that use two internal clutches, one for even gears and one for odd gears, to shift faster and smoother than a human ever could. But to do that, they need an electrical actuator to do the heavy lifting. When your car computer, usually the ECM or TCM, sees high voltage or resistance in that actuator circuit, it triggers this code. It basically thinks the wire is broken or the actuator is jammed. This is not a code you want to ignore. While sometimes it is just a glitch, it can be severe enough to cause internal transmission damage if the gear changes are grinding or banging. You might see symptoms like the engine refusing to crank, stalling out while driving, or the transmission going into limp mode, where it limits your speed to protect itself. So, how do we fix this without throwing money at it? First, do not just run out and buy a new actuator. Start by looking for TSBs, or technical service bulletins, for your specific year and model. Manufacturers often release updates for these specific issues. If that is clear, prop the hood and get your hands dirty with a visual inspection. You're looking for the clutch actuator wiring harness. Since this sits on the transmission, it's exposed to road debris, heat, and vibration. Look for scraped insulation, burn marks, or loose connectors. A bit of corrosion in a plug can cause that high resistance reading just as easily as a failed part. If the wiring looks solid, you'll need a digital multimeter. You're going to want to check for power and ground at the connector. If you see 0 volts where there should be 12, you're tracing a wire back to a fuse or the computer. If you have power, you then check the resistance of the actuator itself against the manual specs. A common mistake here is replacing the expensive control module or the actuator itself when the real problem was just a 10-cent corroded ground strap or a chewed-up wire. Always verify the circuit integrity before buying parts.